Hi everyone, today I will show you how to calculate the volume of any section. It may be a river section or it may be a lake. So in order to perform, we need to have only a digital elevation model. Therefore, we need to add this digital elevation model. Here, this is actually a field. Points are here field digital elevation model. Therefore, I have to add this field digital elevation model. It's okay. Click here, add. Then zoom here. As you can see, this is a stream. This is the darkest one is a low elevation, which is mainly a stream. Therefore, I have to take a section for demonstration purpose. Therefore, in order to perform volume estimation, I have to extract a river section. Therefore, in order to do that, we need to create a shape file for extracting from this digital elevation model. Therefore, here draw a rectangle. Here, as you can see, we can draw here. Okay, now we can elongate. Okay, this is my river section. I have to extract this section from this field digital elevation model, having the higher value of 4087 and the lower elevation range is 830. Therefore, I need to prepare this extracting shape file. Therefore, I draw this rectangle. Therefore, I need to convert this into a shape file. This is not actually shape file. We need to convert this graphics into a shape file. This is actually graphics. Therefore, in order to perform this one, here click this drawing here, then convert. Here it is convert graphics to features. Yeah, click it. Then okay, source layer data. Okay, click here. Now give it a name. Converted shape converted. Okay, or mask. You can say mask. Okay, now click OK here. Now we can add this. Do you want to add the export data to the map as a layer? Yeah, this is it. Now delete this one, or click on the keyboard delete. Now I delete it. This graphics, this is a shape file. It needs to have attribute table here. Yeah, name, you can edit and give a name. You can add also here an elevation. In order to convert to plane, you may need to add a field. Here, give it a name here, elevation. Here, data type double. Give a default 12 here, scale 5 enough, precision most probably 5 enough. Okay, here, yeah. Now this is actually have an elevation field. Now it is a shape file. Therefore, in order to perform volume estimation, we need to extract. This is the largest digital elevation model. Therefore, I have to clip based on my interest. This is my interest section. Therefore, I need to estimate the volume of this stream, the darkest region, from this line to this line. Therefore, I have to slice this digital elevation model. Therefore, In order to slice this field them, click here, okay. Now spatial analyze tool. Now here click extraction, extract by mask. Double click to open it. Now input raster, this is input raster, extracting, yeah, this is here. Now drag and drop, input raster or feature mask data. This is my mask. I have already converted from graphics to shapefile. Therefore now I have to drag and drop here. Yeah, output raster. This is a folder in which we need to save this slice, or we can extract it. Extracted is enough. Now as you can see, there is here extracted digital map here, digital elevation map. Therefore this is a reverse section digital map, elevation map. Therefore this is not relevant. Therefore uncheck or remove this one. This is no longer needed here. Therefore this mask data can be also used as the higher limit for estimating the volume of river section. Therefore you can also edit and enter an elevation. We can also determine at any elevation between 1286 and 1669 meter. Therefore using a range between these two higher and lower value, we can determine the amount of volume of a given river section. Therefore let's say if on the middle, let's take 1300, we want to estimate the volume of a river section between 1286 and 1400. Let's say 400 or 500. Okay, now we need to edit this one. Here click editor tool. If it is not available here, right click here and check this one. Make sure it is checked. Therefore you can easily get here. I already checked this one. If you uncheck this one, there is no editor on the menu items. Therefore in order to add editor tools, right click on the free space here and check here, check it. Now start here, start edit, click this one, mask. I need to convert the elevation. I need to edit the elevation field of this mask. Therefore click this one. Okay, now right click this one and open properties, open attribute tables. Okay, now if we want to estimate between 1286 and 1500, type this one, type the number, and here stop edit. Yeah, do you want to save your edit? Okay, press OK here. Yes, close this one. Now you can see this one on 3D ArcScene. Therefore this is vital, and the other one is this one, extracted. Okay, now as you can see, this is extracted. Therefore we can also visualize this mask, convert this into a thing. Then you will visualize this mask having an elevation of 1500. Therefore we can visualize this by converting it to 18 and open it in ArcScene. Therefore, as you can see, this is converted to file from this extracted raster, and the other one is converted from this mask. This is plantain is converted from mask. This is 18. As you can see, you can visualize in ArcScene. It is actually ArcScene. Therefore, we need to element. This is for demonstration. Therefore, I will go further here and check this one. Yeah, this is our river section. Therefore, click here, go here 3D Analyze tool in ArcMap. Therefore, click this plus sign here, go surface, raster surface, functional surface, sorry, click here surface volume. Is here input surface, you can select extracted here, output text file, give it a name, your file, this is the name for your output file from this ArcToolbox surface volume toolsets final output. Therefore, give it a name, just volume out. Yeah, volume out. Yeah, a reference plane optional below. Yeah, we may not need this plane height. It needs to be greater than 1286. We may just consecutively determine surface volume. We can here with a name 1500, or you can increase 1500. Yeah, leave the other one as a default one here. Press finally here. Okay. As you can see, finally our surface volume is estimated here, and finally open it. There is also here area, 2D area, 3D area, and a volume here taken. Therefore, this volume is trimming the volume at an elevation of 1500. This is, you can see from ArcScene. Yeah, this is the volume from this plane to this triangular network. This one, this bottom level, which is the bottom level for this triangular section, is this one, 1286. The bottom. This is the from this elevation to this 1500. The volume is calculated from ArcMap is this one. We can also export this one, export the output. Yeah, can I export this one in the form of text file or database file here, or info table format, or file database table format. You can, most probably text file is more suitable to compute. You can save here, give it a name here volume out. Yeah, volume out. Yeah, then save. We can we can determine the volume of any section, even if it is a leg. We can determine at any elevation. We can determine the volume as well as 3D area as well as 2D area. Therefore, in such a way, we can estimate the surface volume as well as surface area of our river section, or it may be a lake. Therefore, this is my video tutorial for today. Thank you very much. And this is you can also prepare plain thin rasters. It's so simple. We can visualize here. As you can see, this volume includes the final elevation is this one 1500. Therefore, this is the volume section. This one is volume section. Therefore, we can visualize using ArcScene. And for visualization purpose, I will show you how I imported these two plane as well as this raster into ArcScene. Therefore, the first thing we need to do is just prepare raster. Therefore, I need to convert this feature class into a raster, and I need to just convert this mask. In order to convert into a mask, in order to convert this mask into a raster, we need to use conversion tools. Therefore, click here, from polygon to raster. Okay. To raster is this one. From polygon to raster. Open this one. Here input feature class is mask. Value field should be elevation. We have already entered earlier before, which is 1500. Click this one. Therefore, output raster. We can give plane 2. This is already I have done. Plane 2. Click this one and OK. If the rest as the default one, then we just prepared this raster and this two raster. Therefore, I have to add these two rasters, and I need to convert these two rasters into TN. Therefore, add here these two, plane as well as extract these two. Add. This is already I have done. This is for demonstration purpose. Therefore, in order to convert these two into these rasters into FT, I need to use conversion tools here as well. Therefore, click this toolbox. Here in ArcScene, open conversion tools. Here is one. Open it. 2 kml. Sorry, 2 tin. From raster here. Sorry. Here, the conversion tool is available also for 3D Analyze tool. Therefore, conversion tool available here, 3D Analyze tool. Okay, therefore open this 3D Analyze tools. Click this one. Then there is a conversion here. Like I said, open it from raster to tin. Here raster to tin. Open it. Then convert this extracted and plane of rasters into 18. Therefore, drag this one and drop, or else extract. First of all, we need to convert this one, extracted. Therefore, raster tin. leave the rest the default one. Press here OK. Yeah, as you can see, this is converted to, therefore we need to convert also this raster into a theme. Therefore here also go again and convert, perform repeated work here, drag into or here, press downward arrow, click the second raster, give it a name here, and output folder planting 2, which is I need to rename it because I have already done. Click save here, leave the rest the default one, then OK here. Yeah, now delete these two. As you can see, we have created these two things. You can visualize. Actually, this ArcScene basically used for visualization purpose. Therefore, this is the final elevation in which we need to determine the maximum storage of, or the maximum volume the maximum volumes of river station which in this label. Therefore, this is for demonstration purpose, and we can also prepare in such a way. These are ranges. We can also convert these ranges to a unique value, which is 1500. Go to properties here. Okay. Display source. Okay. Symbology here. Yeah, and check both these two. Therefore, so also that we can represent the whole range with a unique value. Therefore, here click classes. There are 9 classes here. If you count, there are 9. Therefore, click one class only, which is 1500, and so apply here. Yeah. Now, as you can see, as you can see, yeah. Now, as you can see, there is a unique value here, and we can prepare in such ways for visualization purpose. Thank you very much. This is all about for today. Thank you very much.